Okay, so this is the last video in the Pure 1 Maths course. So good job for getting this far. As I said, this is just the basic building blocks for what we're going to be looking at in the next year's book. So the last video we're going to be looking at is non-linear data and using logs to make it a linear data. What we're going to do is basically, if we have a non-linear data, there's not much information we can glean from that. So what we ideally want to do is change it into a linear function, and that way we can use like the equation y is mx plus c, and using the gradient and the y-intercept, get some more information regarding the equation. So there are two separate cases, so let's look at each individual one. So the first one is when we have y is equal to ax to the power of n. So in this case, the variables are going to be our y and x, and a and n are just going to be some constants. Now what we want to do is try and change it into the form y is mx plus c. The way we do that is we take logs either side. So log y is going to be equal to log a x to the power of n. Now at the right hand side, what we can do is use the logarithmic rules, and we can split up into log a plus log x to the power of n. This one we can split up further and say log y is equal to log a plus n log x. What we do now is we now compare it to the straight line equation y is mx plus c. Remember, in this case, log y will be y. The variable was x, right? So that means x is going to be equivalent to log x, which makes n our gradient m and log a the y-intercept c. So if I was to sketch a graph, if I change the axes now, instead of y and x, I'm going to change it to log y against log x. If we were to plot this graph, now it would be a straight line, where the gradient will be equivalent to n, and the y-intercept will be log a. This is very, very important, or is useful for us, because now we can find these a and n values in questions. The second case is when we have now y is a n to the x. So you can see that x and n's have changed its positions. But same thing, we're going to take logs to both sides. So log y is equal to log a n to the x. Split them up using the multiplication rule. So log a plus log n to the x. Log y is equal to log a plus x log n. Once again, let's go ahead and compare it to the equation y is mx plus c. So y will be log a, y. X in this case will just be equivalent to x. Therefore, the gradient m will be log n, and the y-intercept c will be log a. So if we were to plot a graph, now we'll plot log y against x, not log x from before. And this will give us a straight line equation, where the y-intercept will be log a, and the gradient will be equivalent to log n. So using this, we can now solve more difficult questions. So let's take a look at this example here. So we have a graph which represents the growth of the population of bacteria, p over t, and they say that the graph has a gradient of 0.6 and meets the vertical axis at 0, 2. A scientist suggests that the growth can be modeled by the equation p is ab to the power of t. Write down an equation for the line. So basically, we have to understand, is it going to be case number 1 or case number 2? You can see that the variables are p and t, so it's going to be the case number 2. And so what we can do now is say that log p is equal to t log b plus log a. That's going to be the general equation for this particular model. They've told us the gradient, which is 0.6, so that means it's going to be 0.6t plus the y-intercept 0, 2, so plus 2. So the straight line equation will be log p is equal to 0.6t plus 2. In part B, they say using the answers for part A, find the values of a and b. So now what we can say is if 0.6 was the gradient, right? And if we were to look at the case, 0.6 would be equivalent to log b. And same thing for the y-intercept 2, that would be equivalent to log a. So I can say that log b is 0.6 and log a is 2. If there's no base, right, remember we should use the standard base of 10. So I can say log b to the base 10 is 0.6 and log a to the base 10 is 2. Therefore, b is 10 to the power of 0.6 and a is 10 squared. B is 3.98 and a is 100. So the model will be p is equal to 100 times 3.98 to the power of t. That's how we get the a and b values using this straight line equation. And finally for C, it's just this is more like an interpretation question. So they're asking, what does a constant a mean? Well, p is a when t is 0, right? So it's just the initial number of bacteria in this case. So modeling comes up a lot in past paper questions in exponentials. So I would highly recommend you guys trying a lot of these types of questions. So that's the end of the year 1 course. Hopefully everything has been okay for you and you guys have been following along nicely. I've written out some practice exam papers which have a good mixture of all these different types of topics. So you go ahead and practice some of these, and if you are confident with them, then we can move on to the second year of the maths course.